Electrical workings. The electromotive force applied to a circuit drive currents around the circuits. In the process, energy is transferred from the electrical cell or mains supply to the wires and components of the circuit. The total energy transfer to a device depends on its power consumptions and the time spans over which it is used. In these sessions, you will learn how to measure power consumptions, the typical power consumptions of some everyday household appliances, and how to calculate the cost of electricity usage. Power in electrical circuits. In many circuits, it is important to know the rates at which the electric current transfers energy from the source to circuit's components. Earlier, we said that energy transfers were measured by the work done, and the power was defined by the equations. Power equals to work done divided time taken equals to energy transfer divided time taken. In singles, P equals to W divided T, where W is in joules in seconds and P is in J/S or watts. For the definitions of potential difference, we saw that if W is a work done when there is a steady current I in amperes for time t in seconds in a device with a potential difference V in volts across it, as in the figure, that the work done equals to current times and then times the voltage. Current times voltage. Substitute for W in 1 give the P. The power equals to the current times time times voltage divided time. So the power is equals to the current times voltage. And in time t, the electrical energy transfer is energy equals to the power times time. So the energy equals to the IBT, meaning current times voltage times time. So to calculate the power P of an electrical appliance, we multiply the current I in by the potential difference B across it. For example, if a lamp on a 240V supply has a current of 0.25 A in it, its power P equals to IB, which is equal to 240V times 0.25A equals to 60W. This means that there are 60 joules of energy are transferred to the lamp each second. Larger units of power are the kilowatts and the megawatts, where the 1 kilowatt equals to 1,000 W and 1 megawatt equals to 1 million W. In units, watts equals amperes times volts, and it follows from tree that since volts equals to watts divided amperes, the volt can be defined as a watt per amperes and potential difference calculated from 4. If all the energy transferred to thermal energy in a resistance of resistance R, then B equals to IR, and the rate of transfer to thermal energy is given by P equals to B times I equals to IR times I, so I square R. Because resistance voltage is the current times resistance. This, if the current is double, 4 times as much thermal energy is produced per second. Also, P will be equals to P squared divided R. Like if the current is double, 4 times as much thermal energy is produced per second. Also, P equals to P squared divided R. The thermal energy can be transferred to the surrounding by lights and heating. Geometer. Instead of using an ammeter and a voltmeter to measure the electrical energy transfer to an appliance, a geometer can be used to measure it directly in joules. The circuit connections are shown in figures 4.2.33, which is the diode. Electrical supply input, geometer output, appliance. Paying for electricity. Electricity supply companies charge for the amount of energy they supply. A joule is a very small amount of energy and a larger unit. The kilowatt hour is used. A kilowatt hour is the electrical energy used by 1 kW appliance in 1 hour. 1 kWh equals to 1000 joules times 3600 seconds. So kilowatt hour. So 3 by 6 mJ. A 3 kW electrical file working for 2 hours uses 6 kWh of electrical energy, usually called 6 units. Electrical meters, which are joule meters, are marked in kWh. The latest have digit regards like that one. Typical power system appliances are given: DVD player 20W, laptop computer 50W, light bulb 6100W, televisions 100W, refrigerator 150W, irons 1kW, fire 1 to 3 kW, kettle 2 kW, immersion heater 3 kW, and cooker 6.4 kW. Note that the currents required by 6.4 kW cooker is given by I equals to P divided B, which is 6400W divided 230B equals to 28.8. This is too large a current to draw from the mains over the house, and so separate circuit must be used.